all we are trying to do today is to introduce you to the fundamentals of calculus. So let us start with the differential calculus. Differential calculus. Okay, differential calculus. So how do you use the power rule to solve the equations or to derive the equations? How do you use the power rule to derive the equations? The first thing that you need to understand is the commanding words that we have in differential calculus. Number one, you are told to find dy over dx. You're told to derive the equations. Can you derive the equations? You're told to find the derivative. Find the derivative. Or you're told to differentiate. Can you differentiate? Right? Differentiate. Can you just say differentiate the equations? All these are the commanding words. They just mean the same thing. So once you made a question, given an equation, derive, find the derivative, differentiate, they just mean one and basically the same thing. So now, let's have a couple of examples here. Can you find dy over dx? Find dy over dx for each of the following. For each of the following. The first example, let's say you have y is equal to 3x squared minus 3x plus 5. Okay, how do we find the dy over dx for this one, or how do we differentiate this equation according to the power rule? So what you need to bear in mind is that the power rule states that if you have an equation y of the form y x to the power n, where n is the exponent or the power, and the x is the variable, and this one is the coefficient. Then the dy over dx for this equation shall be given as simply dropping this exponent, the power, then you multiply it with the coefficient, you keep the variable the way how it is, you subtract 1 from the exponent. So this is basically the formula that you use when you're using power rule. This is the formula. So going back now to our example, how do you find the dy over dx? How do you find the dy over dx for this equation? So the first thing that we do, just as we said, it is to drop this exponent. So you have 2 multiplied by 3, x to the power 2 minus 1. We know that this 3x, x is raised to the power 1. So it is basically dropping this 1 from, which is the exponent, multiply by -3, keep the x variable the way how it is, 1 minus 1. Then whenever you are differentiating the constant, they're always 0. So you say, what is the derivative of 2? The derivative of 2 will be 0. The derivative of 1 will be 0, as long as it is a constant. So therefore, you say plus this 0, you remain with 6x minus 3. Okay, 6x minus 3. You can't say, okay, let's say 3x minus, let's say 6x minus 3, x to the power 0, because 1 minus 1 is 0. Now, you learned that anything raised to the power 0 is what? Is 1. Any number raised to the power 0 is basically 1. So therefore, the dy over dx shall be equal to what? 6x minus 3. And you find your what? Your solution like that. So that is how you solve this one. So it is 6x, 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 6x minus 3. So 6x minus 3. That is your dy over dx. Let's try now to do another example. Example number let's create example number, another example. Let's have another example. Example number 2 says, can you find the dy over dx for the equation y is equal to 2 over 3x to the power 3, okay, plus 5x squared plus 4. How did you find the derivative? So just as usual, the row is still the same. Drop the exponent. So you have 3 multiplied by 2 over 5 over 3 x. Now, this 3 minus 1, since you are always reducing by 1, we have 2, okay? So 3 here, the exponent minus 1. Then we'll have plus you drop the exponent on 2, you remain with you multiply that with 5x to the power 2 minus 1 again. Then always when you're differentiating the constant, as I said, it becomes what? It becomes 0. So let me just try to erase the board on the top. So what you're going to have is that when you multiply now, 3 times this, it will give you 6 over 3, right? X to the power 2, because 3 minus 1 is 2, plus 2 times 5 is basically 10, and the x, 2 minus 1 is just 1, so it will be 10x to the power 1. So it's as good as just writing 10x, right? Then from here we know that you can easily divide 3 into 6 as 2x raised to the second degree plus 10x, and this will be your dy over dx, right? This is your dy over dx. That is how you use the power rule. Let's do the last example. Let's do the last example. So shall we just say that, let's say that now you have y is equal to 2 over x to the power 2 minus 5x. So how do we deal with this one? From the basics of indices, you know that this expression can still be written as 2 times x to the power negative 2. You can just raise this negative, this expression. Let's say you have 1 over x squared. This can still be rewritten as x to the power negative 2 according to the rule of indices. Or you can still, you're given, for example, let's say you are also given 3 over x to the power 3. This is as good as 3 times 1 over x to the power 3. And you can rewrite this expression again according to the power rule. According to the rule of indices, it can be 3 times x to the power negative 3, right? So having said all this, we now know that we can rewrite this second expression as 2x to the power negative 2 minus 5x. And then we apply the power rule here. We drop the power negative 2 multiplying with 2. Then we have x minus 2 minus 1, negative 5 multiplying with x, x, 1 to the power 1 minus 1. So this will just be basically 5x to the power 0. And so what you're going to have is negative 2 times 2 is negative 4x to the power negative 3, because negative 2 minus 1 is basically negative 3. Then minus 5x to the power 0. Now, anything raised to the power 0, we told you that this is basically 1. So this is as good as 5 times what? 1 here. Just know that there is 1 here. And because of that, we can rewrite this expression now as negative 4x to the power negative 3 minus 5. And right from there, the only thing that you can do is rewrite this equation, if you want, as negative 4 over x. That is to take back this expression down to the power negative 3 minus 5. And this is your dy over what? Over dx. So friends, this is how you deal with the basics of differential calculus, especially, to be specific, how you use the power rule, okay? How you use the power rule. All right.